Hi everyone and welcome to lesson 5.2. Uh, Today we're going to learn the very famous quadratic formula, and I will try to keep this lesson very short. I do want to give the opportunity for you to see a derivation of the formula, which isn't the most important thing for you to know. You just need to know the formula and how to use it. But I would like you to work with it today, so I'm going to give you some opportunity to practice as well. So after this lesson, you can describe the quadratic formula as the formula used to find the x-intercepts of ax squared plus bx plus c equals y. So a parabola in standard form. So last unit we would have found out how to find the x-intercepts of a parabola in vertex form. This unit and this lesson we're finding the x-intercepts in standard form. So our equations are all going to look like this. A parabola in standard form set equal to 0. Okay? So let's start off this lesson by considering what we already know. So if I have a parabola like this, x squared plus 2x plus minus 15 equals 0, remember, we already know how to solve for the x-intercepts in vertex form. So one way to answer this question is to take x squared plus 2x minus 15 and first put it into vertex form. So the way I would do that is I would take my 2x term, take the 2, divide by 2, and then square it, and then I would add and subtract that term. So this is called completing the square. And we learned it last unit. And the reason we add 1 and subtract 1 is because I know that this is a PST, perfect square trinomial, which I can factor. And then I add the two leftover numbers together. So how does this help me? First of all, I know my vertex is -1, -16, but now I can use this to help me find the x-intercepts by setting y to 0 and solving for x. And the way we do that is we bring the 16 over. And then a very important step here is instead of expanding the right-hand side, which I might want to do, because that's what we did a lot in grade 9, instead of expanding, what I do is I take the square root. And on the whole number, or on the integer, I need to make sure that I add the plus minus in front of that. So I'm just going to switch this around, and I know that my x-intercepts to this parabola are x1 will be -1 plus 4, which is 3, and x2 is going to be -1 minus 4, which is -5. So we can say the x-ins are 3, 0, and -5, 0. Now, my next question, part B, is asking us to do the same thing, but now we'll consider turning this from standard form into factored form. So part A is going from standard to vertex form, and part B is going from standard to factored form. And this one's even easier, because if I want to find the x-intercepts of this, I know I can factor this quite easily. It's x plus 5, x minus 3. And now I can use our zero product property to solve for the x-intercepts. So I know x is -5 and x equals 3. Now it's the same parabola, so I'm obviously going to get the same answer that I did in A, and it's much, much shorter. Okay, so this is all fine and good. We can see that the completing the square takes a long time, And we can see that factored form is much better, but not all parabolas, not all quadratics are factorable. So what do we do when we have these parabolas that we can't factor? Are we going to complete the square every single time? Well, the answer to that is actually yes and no. What we do is we complete the square once using variables, and then we take that formula and use it from then on. And that's what we mean by the quadratic formula. So we start with standard form, okay? And standard form of a parabola has a y, okay, to indicate that it's a whole function, it's the whole parabola. But then we set the y value to 0 to indicate that we are looking for the x-intercepts. Okay, so in your package, you should have the derivation of the quadratic formula, and feel free to skip what I'm doing now, but I did want to show you the derivation really quickly because it's not beyond you. Yes, you can skip this if you want to, that's totally up to you. But if you're curious at all, I'm going to show you how we derive the quadratic formula from y equals ax squared plus bx plus c. So what we want to do is find the x-intercepts. We set y equal to 0. And essentially what I'm going to do is complete the square and solve for x. Okay, it is a long one, so either be patient with me or you can skip ahead to the next thing. So how do I complete the square? If you guys remember, we would factor the a out of the x terms. And the way I factor a out of b is by writing it as b over a. If you don't believe me, just expand the a back in and you'll see that b over a times a is b, so that's how you divide b by a. And if you recall, what we do is we take the middle term, we divide it by 2, so b over a divided by 2, believe it or not, is b over 2a. And we take that term and we both add it and subtract it within this set of brackets. Okay, then what do? Well, we take this guy here, we make sure to multiply it by a, and then we take it out of the bracket. So 0 equals a x squared plus b over a x plus b over 2a squared. And then on the outside of the bracket, I'll have negative a times b squared b over 2a squared plus c. Now the whole reason I did this was so I could factor this bracket. So let's do that. 0 equals a, and if you remember, this is kind of nice that we left it in this form, because when I factor it, my result is x plus b over 2a. Okay, and I'm not going to expand this quite yet, because what I want to do at this stage is I want to divide all my terms by a. So I'm going to divide this term by a, I'm going to divide this term by a, and I have to divide the last term by a as well. Okay, so at least, okay, we can get rid of the a terms in those first two terms. X plus b over 2a squared minus b squared over 4a squared, okay, plus c over a. Now, what I want to do is eventually I'm going to combine these last two terms. So what I need before I do that is I need to find a common denominator. So I need a common denominator of 4a squared. So I need to multiply this c over a term by 4a over 4a. That's an equivalent fraction. What I'm going to do is actually two steps at once here. I'm going to simplify this, but I'm also going to bring these two terms over to the other side. Okay, so I'm going to get b squared over 4a squared minus 4ac over 4a squared equals x plus b over 2a squared. And now I'm actually just going to flip the left-hand side and right-hand side, while at the same time writing my right-hand side over the same denominator. Okay, that was the whole point of finding a common denominator. And if you remember, guys, at this point when we completed the square, what we would do is square root both sides. Not when we completed the square, when we were solving for x. So we have plus minus. So now I get x plus b over 2a equals plus minus the square root of b squared minus 4ac over 4a squared. Now to get x by itself, I'm going to bring the b over 2a term to the other side. I'm going to do something here that makes it look a little nicer. I am going to take the square root separately of the numerator and denominator, and I know that the square root of 4a squared is going to be 2a. Now technically I'm done, but since I have a common denominator between these two terms, what I can do is write the whole formula over 2a. So I tried to do that quickly. Sorry if I went a little fast, but essentially I'm just showing you in live time one way to derive the quadratic formula. But really, guys, all you need to know is what's in these two boxes here. To find the x-intercepts of y equals ax squared plus bx plus c, we can use a quadratic formula. Now, you might be wondering why we have x1 and x2. Well, that's because sometimes when you have a parabola, you have two x-intercepts. And you've done these questions already with numbers. Okay, but what I want to draw your attention to is that one of the roots is going to be the plus root. The x-intercept is going to be the plus x-intercept, and one is going to be the minus x-intercept. Okay, so you've seen this before with actual numbers. Now, what you have to do, unfortunately, is memorize the formula. We'll probably give you the formula for the most part, and then use it. So let's jump right into an example, and if you'll notice, this is the same example that we had before. X squared plus 2x minus 15 equals 0. Now, kind of the tricky part here is figuring out what a, b, and c are. So remember, I'm comparing this to ax squared plus bx plus c. So I can see that the a value is 1, the b value is 2, and the c value is negative 15. So what I'm going to do is plug it into my formula. I'm going to get negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, and now we simplify. x1 comma x2, negative 2 plus or minus. This is going to be 4 plus 60 over 2, and lucky us, this ends up being the square root of 64, which is a whole number. All right, so x1 comma x2 is negative 2 plus or minus 8 over 2. So x1 is negative 2 plus 8 over 2, which is 3, and x2 is negative 2 minus 8 over 2, which equals negative 5. So we've seen this already twice. Okay, but now consider the fact that we can't maybe factor the next question. We might have to use a quadratic formula because completing the square from the beginning just takes too long. Okay, So it says sketch the graph, and how does the quadratic formula relate to the axis of symmetry and the roots? And by roots, remember, we need x-intercepts. So I'm just going to just roughly sketch this. I know I have an x-intercept at 3. I have another one at x is minus 5. And I know my a value is 1, meaning this is going to face up. All right, so this is going to be a big parabola, probably bigger than I wanted. But we can see that, you know, the roots are where we think they are. But the question here is asking about the axis of symmetry. So how do we find the axis of symmetry here? Well, I can see pretty obviously that the x value, we call it xv, the x value of the axis of symmetry is going to be the midpoint of the roots. The axis of symmetry is -1, and that makes sense, okay, because what I have here is -1, and then I'm adding 4 or subtracting 4, I guess we can write that as -4, from the axis of symmetry to get the roots. So the axis of symmetry is always going to lie right in the middle of the two x-intercepts. This will become useful later. Okay, so let's get right into this. So what I'm going to do is I'm going to solve two of these. I'm going to solve A, and I'm going to solve G, and then I want you guys to do the rest, and I'll have the solutions ready at the end of the video. Okay, so pause the video after I'm done here, and you can finish the rest. Okay, A is 1, B is 6, C is -27, x1, x2 is -b plus or minus square root of b squared minus 4ac over 2a. 4 times 27 is 108. x1, x2 is -6 plus or minus 36 plus 108, which is 144. That's nice. So x1 is going to be -6 plus 12 over 2. x1 is 3. And x2 is going to be -6 minus 12 over 2. x2 will be -9. All right, so what happens when your quadratic equation looks something like this? Well, what we have to do is ensure that one side equals 0. So what I'm going to do is bring everything over to this other side and combine like terms. So I'll have 3x squared plus x squared minus 2x subtract x minus 5 minus 4. 4x squared minus 3x minus 9 equals 0. Maybe I could factor this, but let's just use a quadratic formula because we were asked to. So I'm going to get x1, x2 is -b plus or minus the square root of b squared. Remember, this is -3 in brackets, all squared, minus 4ac over 2a. x1, x2 is 3 plus or minus. This will be 9 plus 4 times 4 times 9 is 144. So I get the square root of 153 over 8. x1, x2 now. Let's remember that this is divisible by 9. Okay, so I should try to reduce these if I can. So x1, x2 is 3 plus or minus 3 root 17 over 8. So x1 is going to be 3 plus 3 root 17 over 8. And x2 is 3 minus 3 root 17 over 8. All right. Okay, so I'm going to do the last question now, and then I want you guys to go back and complete B, C, D, E, F, and H, and make sure that your answers are correct. All right, so in a warm-up, Mr. Davis chips a golf ball to Mr. Shannon, who misses the catch. So it's a parabolic arc. The height of the ball in meters above the ground after t seconds is modeled by the equation h is negative 4.9 t squared plus 8.4 t plus 1.5. Answers should be given in exact form, then rounded to the nearest hundredth. Okay. After how many seconds does the ball land on the ground? So, if we start with h equals negative 4.9 t squared plus 8.4 t plus 1.5, we could theoretically complete the square, or we could remember the formula for completing the square, which is the quadratic formula, where it automatically gives us the x-intercepts. So what we can do is call this T1 comma T2 is negative b plus or minus the square root of b squared minus 4ac over 2a. All right. T1, T2 is negative 8.4. Now it's asking us to do this exactly, so let's make sure we get it right. Plus or minus 70.56 plus 294 over negative 9.8. T1 over T2, negative 8.4 plus or minus the square root of 364.56 over negative 9.8. All right. So we know that if we have a negative, 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 that will give us a positive number. So actually, let's write this out twice. So T1 is going to be 8.4 plus the square root of 364.56 over negative 9.8, negative 8.4 minus 364.56 over negative 9.8. So we know, maybe I'll draw it like this. We know that the parabola is going up and coming down. So one of these solutions is going to be the lower solution, one's going to be the higher one. So let's put this in our calculators. So we know that the square root here, so I have it down, is 19.09345. And that gives us a T1 value of negative 1.091 seconds. And it will give us a T2 value of 2.805 seconds. So this lower number is negative 1.091. The higher number is 2.805. So I know t equals 0 somewhere in there. And the ball lands on the ground at these two answers. Okay? The ball lands at 2.805 seconds. Now I know I asked you for exact and rounded to the nearest hundredth, okay, which is technically 2.81 seconds, and that's the final answer. Okay, what is the max height? So you might think that it would be hard for us to figure this out, but actually, because a parabola is symmetric, what we can actually do is figure out the midpoint, so the x value of the vertex, by taking the midpoint of the two intercepts, and then we can plug that in to find the maximum height. So to find, and technically it's TV, not XV, because we're using T instead of X, TV is going to be negative 1.91 plus 2.805 divided by 2. TV is negative 1.091 plus 2.805 divided by 2. It is 0.857 to 3 decimal places. So to find the height at that time, what I'm going to do is sub into negative 4.9 t squared plus 8.4 t plus 1.5. Negative 3.5988 plus 7.1988 plus 1.5. Okay, so I'm getting that the height is 5.1. So the max height is 5.1 meters. Okay, so I'm going to stop talking now. You'll be able to find the answers on Schoology on our shared Google Doc. And yeah, good luck, guys. I will be in soon if you need any help with this. Take care.